This is 11.2 areas of trapezoids, rhombi, and kites. Scan the text in 11.2. Write 2 facts you learned about trapezoids, rhombi, and kites as you scan the text. So we actually had an entire chapter last semester on trapezoids, rhombi, and kites. They are all quadrilaterals. So we might write something like that. Or even scanning 11.2 specifically, you might write down something like the definition of a trapezoid or the 3 different formulas for finding the area of a trapezoid, something like that. So we could say area formulas for each. Okay, again, my suggestion is that you kind of read through the section and try to do this first page on your own, and then use this video to replay the first page and see how you did. Fill in each blank with the correct term or phrase. The blank is any side of a triangle. Well, we learned last section that that would be the base of a triangle. So we said we're getting away from the idea that the bottom is the base. We know that the base and the height are whatever form that right angle. A quadrilateral with both pairs of opposite sides parallel is known as a parallelogram. We again reviewed that last section, and we had an area formula for a parallelogram, which was the base times the height. So the last one has to be a trapezoid. Is a quadrilateral with exactly 1 pair of parallel sides. So just to remind yourself, a trapezoid looks like this, where these 2 would be my parallel sides. Define the height of a trapezoid in your own words. So you can read through 11.2 and it has the exact definition for the height, but the height of the trapezoid is going to be very similar to the definition of the height of a parallelogram and the height of a triangle. So I could say the height of a trapezoid is the perpendicular distance between its 2 parallel sides. And just to remind yourself, perpendicular means it's forming a 90-degree angle. So if I were to draw out a trapezoid again here, I could say this is my height. It's going to be whatever forms the right angle and shows me the distance from those 2 parallel sides that we call bases. Area is a word that is used in everyday English. Find the definition of area using a dictionary. Explain how its English definition can help you understand its meaning in math. So if you look up the definition for area, it says area is any particular extent of space or surface. Now when we're talking in math, area is going to be the measure of a plane or a curved surface. I think of area as it's the amount of wrapping paper to wrap something or to cover something. That's why we even said last section that area is always in units squared. So I could say area is any extent of space, and in math, it's that particular measure in numerical form. So let's get into some formulas. Derive the formula for the area of a trapezoid. So if we take this figure as a whole, what's outlined in red, I see, is a parallelogram. It says to take a basic trapezoid and make a glide reflection of it. So glide reflection is where we're going to translate and then reflect. We learned that in chapter 9. So if we take this first trapezoid and we move it to the right and reflect it, I get the second trapezoid. Putting them together, I have the parallelogram. These two congruent trapezoids, because we know a glide reflection always produces something that's congruent, it doesn't change its shape or size, form a single parallelogram. So if you write out the area formula for a parallelogram, you would have to take the entire base, which in this case would be base 1 plus base 2, times the height, which is still h. Therefore, if you wanted just the trapezoid, you didn't want both, you would have to take half of that. 1/2 base 1 plus base 2 times the height. That would be our area formula for a trapezoid. Kites and rhombi are next. In the formula for finding the area of a rhombus or a kite, your area is going to equal 1/2 d1 times d2. Reading section 2, you'll see that d1 and d2 represent the diagonals. So this picture gives me a kite, not a rhombus. So my area formula would be 1/2 the first diagonal, which is 10, times the second diagonal, which is 18. 18 times 10 is 180. Half of 180 would be 90. And I know because I'm talking about area, it's always in units squared. So two formulas to represent three figures. We have the trapezoid, 1/2 base 1 plus base 2 times the height. And both a rhombus and a kite have the same formula, 1/2 diagonal 1 times diagonal 2. So we're going to cross this out because we have it all written up top. And I'd like you to head back to your first page of notes so you can fill in your new formulas. So again, trapezoid, 1/2 base 1 plus base 2 times the height. Height is always our perpendicular distance, and the bases are always what connect or form that right angle with the height. Rhombus and a kite share the same formula, 1/2 diagonal 1 times diagonal 2, where this entire distance would be one diagonal, and this entire distance would be the other diagonal. So now you'll head over to work on the 11